graph, and what is loop, what is node, and what is subgraph, what is oriented graph, and what is tree, what is core tree, and how you write the incidence matrix, what is further incidence matrix, what you taken about the rows and the columns, like that you have to see in the last class, that is the graph theory. So now we go to the another topic, that is the tie-set matrix. Tie-set matrix. Whatever tie-set matrix are there, or whatever the cut-set matrix are there, first of all, when you have to draw the tie-set matrix, you have to frame the tree. So the fundamental loop, or this is also called fundamental loop or F loop, or it is called as tie-set. Fundamental loop or F loop is formed by adding a link to tree. By adding a link to tree. So the fundamental loop contains only one link. So the number of loops is B minus N minus 1. So the tie-set matrix is the order of B minus N minus 1 into B. So here it is the fundamental loop or tie-set is formed by adding a link to tree. So the fundamental loop or F loop is a loop which contains only one link and one or more things. So when a network is there, so for that network, so if it form a loop, what is the tree? It will be connect to all the nodes but does not form a closed path, like that. If any loop must be there, for that loop there is only one link must be there, remaining all are twins, remaining all are twins, only one link must be there. So the number of F loops will be given to the number of links. The fundamental loops is equal to the number of how many links are there. For each loop there is only one link must be there, or any number of twins must be there. So if for the network, if suppose there is 3 links must be there, equal to the 3 loops, like that. Fundamental loop matrix is represented with letter B. It is represented by the letter B. It is also called fundamental circuit matrix. It is also called fundamental circuit matrix and tie-set matrix. It is also called fundamental circuit matrix and tie-set matrix. This matrix gives the relation between branch currents and link currents. Branch currents and link currents. So tie-set matrix is a fundamental loop or F loop. So while you have to draw, we have to find out the any matrix equation. So first you have to what to do? So that is the F loop. We have to frame one loop. For that loop, there is only one link must be there, but any number of things are there. Number of links are there. For each loop, one link. So for how many links are there? Suppose in the circuit there is 3 links must be there. The loops are also 3. So fundamental loop or F loop is a loop which contains only one link and one or more things. So the number of F loops will be given will be equal to the number of links. Fundamental loop matrix is represented with the letter of B. It is also called fundamental circuit matrix or tie-set matrix or fundamental loop or F loop, whatever you have to, and they explain about the letter. What is the letter of tie-set matrix? It is B. And tie-set matrix. The matrix gives the relationship between branch currents and link current. Tie-set matrix. If there are n nodes, and B branches. So for any network, there is a number of nodes must be there. If there are n nodes and B branches are present in a directed graph, then the number of links present in a code tree, which is corresponding to the selected tree of a given graph, will be B minus n plus 1. So for any network, there is a number of nodes must be there. So that means if suppose if the circuit will be 4 nodes, network will be, and for 4 nodes there is a 6 branches or there 5 branches, for there are 4 branches must be there. So if there are the 5 branches or 6 branches must be there. If there are n nodes and B branches are present in a directed graph, then the number of links present in a code tree, which is correspond selected tree of a graph, will be B minus. So branches are 5. So nodes are 4 plus 1. So like that 6, or it will be take the equation. So B minus n plus 1. So the fundamental loop matrix will be B minus n plus 1 rows and B columns. So we have to multiply that B column, B minus n plus 1 into B. So the fundamental loop matrix will have B minus n plus 1 rows and B columns. Here rows and columns are corresponding to the links of code tree and branches of given graph. So the fundamental loop matrix will have B minus n plus 1 rows and B column. Here rows and columns are corresponding to the links of code tree and branches of a given. Hence the order of fundamental loop matrix will be B minus n plus 1 into B. Hence the order of fundamental loop matrix will be B minus n plus 1 into B. Then the elements of fundamental loop matrix will be having one of these 3 values, plus 1, minus 1 and 0. That means if in the instance matrix also we have to, there is a plus 1, minus 1, then 0. That means if it will be towards the node, we have to take minus 1. If it will be away from the node, you have taken plus 1. If it will not related to that node, put it as the 0. Next, the value of the element will be positive for the link of selected F loop. That means here for the instance matrix towards and away and it not related. For the tie-set matrix, what we do is we will frame one loop. So in the network there is 1 loop, 2 loops or 3 loops, number of loops must be. If you take in 1 loop, the link direction, whatever the link direction will be take, there we have taken for that link direction. Link direction and loop direction will be same. So when the direction, when it will be starts to the link and it will be goes to the second twin and the third twin, if the direction will be same, loop direction and the element direction must be same, then put it as positive. Either it will be link or whatever it may be. Positive. If the link of the element direction and the link direction will be, loop direction will be opposite, then it minus 1. If it not be related, then it will be 0. So the value of element will be plus 1 for the link of the selected F loop. The value of elements will be 0 for the remaining links and twins, which are not part of the selected. If it will be not part of that, then we have taken will be 0. If it will be the negative, that means if the direction of ping current is selected F loop is same as the F loop link current, then the value element will be taken as the positive. If the direction of ping current of selected F loop is opposite to the F loop link current, then the value of the element will be minus negative. So here we observe that the elements of fundamental loop matrix will be having one of these 3 values, that is plus 1, minus 1 and 0. If the value of the element will be positive, So will be positive. So we have taken that link direction, loop direction will be start from the link for the link of selected F loop. So if this value of the elements will be 0 for the remaining rings and things. If the direction of swing means things or chords, links. Swing current, that means swing means it does not, there is a which it does not form a closed path, but it touches the all nodes, that is called tree. So there is the whatever the nodes will be touches, that is strings, and the links will be links. Current of selected F loop is same as that of F loop link current, then the value of element will be positive. If the direction of swing current of selected F loop is opposite to that of F loop link current, then the value will be negative. Procedure to form a Tyson matrix. First, select a tree of given directed graph. Next, by including one link at a time, we will get one F loop. So first you have to select a tree. Then by including one link at a time, we will get one F loop. Fill the values of elements corresponding to this F loop in a row of fundamental loop matrix. Next, repeat the above steps for all links. So for example, we take this problem. For this Tyson matrix from the given, form the Tyson matrix from the given tree at a direct graph. So generally they given the tree, otherwise they given the network. You have to frame the graph and you have to represent the oriented graph, and then you have taken the tree. So it touches the all nodes, but it does not form a closed path. So the whatever the 1 to 2 and 2 to 3, it will be called as a links. So the above tree contains 3 branches. So 3 branches, what are there? So D, E, F are 3 branches. Hence the branches A, B, C will be the links of the core tree. Will be links of the core tree. Remaining here and whatever the above figure, that will be called as the A, B, C will be the links of the core tree to the above tree. By including one link at a time to the above tree, we will get one F loop. So there will be 3 F loops since there are 3 links. These 3 F loops are shown in the following figure. So here when you observe. So first F loop. So D, E, F are the 3 branches. So first A is one link for this. Next, for second loop, 1, 2 is one another link. And for third loop, 2, 3 will be another link. So here so when you have to frame a loop, for each network, that means each loop, there is only one link must be there. Number of tree branches are there. Here also there is only one link. Tree branches are 2. Here also there is only one link. Tree branches are 2. So for each link there is only one loop. If 3 links must be there, 3 F loops must be obtained. So in the above figure, the branches which are represented with colored lines from F loop, we will get the row-wise elements values of Tyson matrix from each F loop. So the Tyson matrix of the above considered tree will be B is equal to. So when you observe here, for A loop, there is D, A and D, F, E. A and D, F, E. That is, when you observe here, 1, so the direction will be same for 1. And second, it does not will be related, so put it as to 0. And 3 will be 0. So we have to assume the direction. So when I am assume this direction, so for first loop, A, the link 1 will be same direction, and then it goes to the D. So at the D part, it will becomes, when the direction is downwards, it will be opposite. So minus 1. So and then it goes to the what loop? It goes to the F loop. Then the direction will be opposite. So it will be minus 1. Same thing. For this loop, it will be related to DVE. So B is the same direction, put it as 1, and it will comes down. E is also same direction 1, and D is also same direction. So 1, 1, 0, remaining all 0. For this loop, it will becomes to the CEF. For CEF, C will be same, but F will be also same, and E will be minus the opposite. So it will be minus 1. Remaining all zeros. Remaining all zeros. Like that, we have to tie-set matrix. So for the tie-set matrix, first you have to draw the graph, and then the oriented graph, and then you have to frame the tree. For that tree, you have to assume the F loops. For each loop, there is only one link must be there. Number of trees must be there. For the tree link direction will be same as the loop direction. If the both element direction must be same, then put it as +1. If it will be opposite, 1. If it will be not equal, it will be 0. Next one, we go about the cut set matrix. So fundamental, these tie set and cut set are two or same manner. Tie set and cut set. Fundamental cut set or F cut set is the minimum number of branches that are removed from a graph in such a way that original graph will come to isolated subgraphs. The F cut set contains only one twin and one. So the number of F cut sets will be equal to the number of links. So when you have to take the fundamental cut set matrix, what we do means, so in the tie set matrix, the preference will be link. For one loop, there is only for loop equal to one link. If number of links is there, number of loops must be there. For cut set, if there is only one tree branches must be there. For tree branches is equal to cut set matrix. If any number of n number of tree branches is there, 3 numbers of cut sets must be there. Cut set means it is a cut the graph. When you take the part of the K, so you have to cut that one piece. Like that, you have to cut the graph. It's nothing but the cut set matrix. So fundamental cut set matrix is represented with the letter C. This matrix is a relation between branch voltages and twin voltages. Branch currents and link currents is nothing but the tie set. Branch voltages and twin voltages is nothing but the cut set matrix. If there are n nodes and b branches are presented in a direct graph, then the number of things present in a selected tree of a given graph will be n minus 1. N minus 1. So the fundamental cut set matrix will be n minus 1 rows into b columns. N minus 1 rows into b columns. Here, rows and columns are corresponding to the twin of selected tree and branches of a given graph. Hence, the order of fundamental cut set matrix will be n minus 1 into b. N minus 1 into b. First, here also, the elements of fundamental cut set matrix will be having one of these three values, that is +1, -1 and 0. The value of element will be +1 for a twin of the selected F cuts. In the tie set matrix, the value will be whatever the direction will be. The value of the link will be +1. Here, fundamental cut set matrix, the value of twin or tree branch is +1. The value of elements will be 0 for the remaining twins and links which are not part of selected. If for cut set it does not related to that part, then put it as 0. If the direction of link current of the selected F cut set is same as that cut set twin current, then the value of element will be plus 1. So if it will be the direction will be same, put it as plus 1. Direction will be opposite, then it will put it as negative. So for cut set matrix, for each cut set, there is only one tree branch. Number of links must be there. If the direction of the link current of selected F cut set is opposite to that F cut set string current, then the value of element is -1. If it will be the opposite, then it will be the -1. Procedure to form a cut set matrix. So, follow these steps in order to find the fundamental cut set matrix in a directed graph. First, you have to what to do? Select a tree of a given directed graph and represents the links. First, you have to select the tree. By removing one twin and necessary links at a time, we will get one cut set. Fill the values of elements corresponding to this fundamental cut set in a row of fundamental cut set matrix. That means if you have to select the one cut set matrix, there is only one twin must be there. Number of links must be there. But that will be cut from the graph. That will be cut from the graph. Only one link and only one twin, that is tree branch, and number of links must be there, but it will be cut that part. Repeat the above steps for all tree branches. So here from the cut set matrix form for the given graph, form the cut set. So this is graph. So there are totally 6 branches and 4 nodes. So cut set means we have to taken will be the tree branches. So you have to cut first tree branch DBA, and second. So when you have to cut here, the part will not be cut for the second node. So you have to cut like this. That is A, B, E, C. And the third, you have to cut B, A, C, F. So I will see here. By removing one twin and necessary links at a time, we will get one F cut set. So there will be 3 F cut sets since there are 3 twins. So for in number of twins must be there, that is equal to that much of cut sets. So when you observe here, so we have to cut this graph. So the part will be removed. So for this cut set, only one tree branch must be there. So links must be number of. For this cut set, so it does not cut here. It will be cut from A to. So here we have to draw that from A to, will be cut from A also. So when you cut here, it is not a part. It will be cut A also. So it will be go from A to, it goes to the outside, and it will be cut A, C, F. So we will have 3 F cuts matrix. So C1, C2, C3, we will get the row wise element values of fundamentals. So cut set matrix from each F cut sets, the fundamental cut set matrix of the above considered tree will be C equal to C1 minus 1. So for this, so for D, link direction, tree branch direction will be same. Whatever the tree branch direction, you put that direction. For D, same direction, put it as 1. For B, it will be opposite, put it as -1. For A, same direction, 1. Remaining will be 0. So like that here also, we have to see that here also there is the cut set will be B, C and E. And here also the cut set will and A also. And here also the cut set will be that is A, C and F. So but the F must be here when you observe that D, here E and here F. These 3 are 1, 0, 1, 0, 1, 0, 0, 0 unit matrix. Identity matrix. These 3 are. So when you observe when these are identity matrix, your problem will be right. For tie set also, when you observe for the tie set also, the problem will be the last column. That means whatever the links you have to taken, that will be unit matrix. So when you observe this, 1A, what are the links? A and B and C. So A, B, C, 1 0 0 0 1 0 0 0 1. So what is the basic difference of tie set and cut set means? Tie set, we have to consider the loops in the form of links. How many links must be there? That is equal to loops. For cut set, how many tree branches must be there? Twins are that is equal to cut set. So link direction is same as the loop direction. Here the tree branch direction, twin direction is same as the cut set direction. So if the element direction will be same, put it as 1. Otherwise it is -1. It does not related, put it as 0. If the cut set direction will be same, then it will be put it as +1. Not opposite -1. It does not related to 0. So whatever the links are there, that will be get unit matrix, and identity matrix. Whatever the twins are there in cut set, that is called the identity matrix. So based upon the loops, links, it will be called as tie set. Based upon the loops, cut sets, twins we have there, it is called as cut set matrix. So this is upon the tie set and cut set matrix. Thank you.